With the next problem, we have the function defined by f of x is x to the fourth minus 3x squared plus 2, and we're first asked to find the zeros of f. To find the zeros of f, there are a number of different ways. We could use synthetic division, starting with x equals 1 as a root, and that would give us the roots from that. Another way to do this is to treat this or to solve this in quadratic form. It's not a quadratic. However, if we let u equals x squared, then we would have the quadratic f of u is equal to u squared minus 3u plus 2, which then factors to u minus 2 times u minus 1, and that will equal 0 when u is equal to 2 or u is equal to 1. So going back to u is equal to x squared, we would have u is equal to x squared is 1, u is equal to x squared is 2, and so we would have the roots x is equal to plus or minus 1, x is equal to plus or minus the square root of 2. Again, this is one method for finding this. I could have used synthetic division also, starting with x equals 1 as a root. And that's it for part A. For part B, we want to write an equation of the line tangent to the graph of f at the point where x is equal to 1. And at the point where x is equal to 1, we would have the point x comma f of x, or 1 comma f of 1. And since we know that 1 is a 0, that it would be 1 comma 0. So we have the point 1 comma 0. Next, we need to find the slope of the tangent line, which is the first derivative, and that would give 4x to the third minus 6x, and f prime of negative 1 would be 4 times 1 minus 6 times 1, or 4 minus 6 is equal to negative 2. Using the point slope form, our y1 is 0, our slope is negative 2, and x1 is 1. And so the answer to part B would then be y is equal to negative 2 times the quantity x minus 1, or negative 2x plus 2. Alright, and that gives us part B. For part C, we want to find the x-coordinate of each point at which the line tangent to the graph of f is parallel to the line y equals negative 2x plus 4. Basically what that's saying is we want to find the x-coordinate of each point on our original curve where the slope of the tangent line is negative 2. So since the slope of that linear equation is negative 2, we want to find all x such that f prime of x is equal to negative 2. That's what we're asked for here. The x-coordinate of each point at which the line tangent to the graph of f is parallel to this line. And lines will be parallel when they have the same slope. So we're looking for everywhere on the curve where the derivative is equal to negative 2. There, the tangent lines will all have a slope of negative 2 and will all be parallel to this line, y equals negative 2x plus 4. So we already have our derivative above, and we just set that equal to negative 2, bring everything over to one side, factor out a 2, divide both sides by 2, and when we solve this for x, we will find all x such that f prime of x is equal to negative 2. Now to solve this, we can't do the same type of substitution that we did above, but we can use synthetic division, and you should see that 1 is still a solution to this because 2 minus 3 is negative 1 plus 1 is 0. So we set up the synthetic division, remembering to put a 0, a placeholder, wherever there's no term. There's no x squared term here. We bring down the 2, multiply by 1, add the next column, multiply by 1 again, add the next column, and multiply by 1 again. And we end up with 0, which tells us that 1 is a root of the derivative as well. And so we have x minus 1 times the quantity 2x squared plus 2x minus 1. At that point, we'd need to use the quadratic formula to find the zeros of 2x squared plus 2x minus 1, and I do that here so you can pause and see the solution.